Bismillahirrahmanirrahim. How are you, dear student? Hope you are fine, good, and doing great. Your physics teacher is Yaul Haq. In this video, we also study about the centripetal force. Like you know what is centripetal force? In the last video, we already discussed about the definition and a little bit explanation and formula of the centripetal force. Like what is centripetal force? The force which try to keep the object in a circular path. So this is called centripetal force. Now we today we are trying to study some formula of the centripetal force. For example, on the next page also we discuss this issues like the general formula of the centripetal force, you know, is mv square divided by r. This is the general formula, but if the object is on different position, like is horizontal position and on vertical position, or in between these two, so what types of formula we can use for the horizontal, if the object is in horizontal position or in vertical position or in this position. So let's see one by one on the next page. Okay, let's see here. When the object is in a horizontal, like if move in a circle, but the object is in horizontal position, mean this position. So simple, we can use the simple formula T, like a tangent force is equal to centripetal force, which is equal to mass times centripetal acceleration, or we can also use this formula T is equal to F, which is equal to mv square by r. We can also use this formula for, but if the object is in horizontal, like if the object moving around the horizontal circle, mean in this position, now this is the whole this is the different position and this is the different formula. Like for example, the object start from A in this position, let's it point A, then you know that the weight is also downward in this position, and the tangent force also both are in the same direction. Weight and tangent force or centripetal force both are in the same direction. So in this case we will add the weight, mean the gravity force with mass. So in this formula, at the vertical side when the object is on A, so we will use this formula T plus W is equal to mv square by r. This part is same, but the problem is on the left hand, so we can use this formula T plus W is equal to m, and in this case the tangent force or centripetal force will be minimum. Okay, next point, when the object reach to point B. So already we discussed when the object is in horizontal position, mean the horizontal position is E and B. So we can use the simple formula already I mentioned here, T is equal to F, which is equal to mv square by r. And next, when the object is reached to point C, mean this point, so now in this case we can use the formula adding the cosine theta as well, here making some angle with the downward vertical side, T minus W cosine theta, and the right hand of the formula is same, mv square by r, no problem. When the object is reached, when the object is on exactly D position, mean downward vertical side, so then in this case the tangent force will be maximum because it is opposite to the weight, it is opposite to the downward weight. So we can, now the tangent force is upward and the weight is downward, so in this case we will minus the weight from the tangent force. Why? Because this is the tangent force is in upward direction and the weight is in downward direction. So again the right hand of the formula is same, and in this point the T will be maximum. Okay, another point is here, let's suppose if the object is here, so then we will use this formula for to find the centripetal force, T plus W or F plus W cosine theta, and the remaining part is same. So these are the horizontal and vertical different position or situation for a body that we will find the centripetal force or tension force on a circle at different position. Okay, hope you understand. Let's see on the next page. We will solve a simple example which will clear more this formula, and also I will give you some homework that you will solve the question. Okay, let's see here on the next page. Okay, let's see this example. They ask in this example of 0.5 kilogram object is rotated in a circle in vertical plane, mean the position of the object is vertical, sometime is in up direction, sometime is in downward. They want to find the tension force in this position and this position. Like in a vertical plane, at the end of 1 meter long roof, mean this roof radius is equal to 1 meter, in roof twice in a second. Find the maximum and minimum tension. Mean in this position we already said that here is the minimum, the tension will be minimum, but in this position when the object reach to this position, the tension force will be maximum. So let's see the first, right, the given value mass is equal to 0.5 kg. Now we will convert the mass into weight, because we need the weight which is equal to m times g, which is equal to m is 0.5 multiplied by 10, which is equal to 5 Newton. Okay, the next one, we know that the angular speed is equal to 2 pi radian per second. Now they said the roof is long and twice in a 1 second. Mean in 1 second they complete the 2 circle in 1 second. So 2 pi plus 2 pi in 1 complete circle, this is equal to 2 pi, but in 2 complete circle this is equal to 4 pi in 1 second, like twice in a second. So this is equal to this angular speed is equal to 4 pi over second. Now what is unknown? The next thing, the roof or radius is equal to 1 meter long. This is also given. Now T max is unknown and T minimum is unknown. So we know that if I want to find the T max, the first one, T max is minus W. Like if I want to find the T maximum, which is equal to, the formula is given, m omega square dot r. Just putting the value T minus this is equal to, the weight is equal to 5 Newton and m is 0.5. The original value of the omega square is 4 pi divided by second whole square, and r is 1 meter. This is also given in the question. So this is equal to 5 Newton, which is equal to 0.5, and if we square this one, so in the question they ask take the pi value is equal to 3. So this is 4 square is equal to 16. So if we take the pi value 3, so 3 square multiplied by 9, second will be square dot 1 meter or multiplied by 1 meter. So T minus 5 Newton is equal to, this is also kilogram. If we multiplied 16, 9, 0.5 and 1, so the remaining value is equal to, like this will be equal to 72 kilogram meter per second square. So kilogram meter per second square, which is equal to 72 Newton. Like this is force, the kilogram meter per second square is equal to force. So this will be equal to 72 Newton. And here T minus 5 Newton. If we shift the value here, so T will be 72 Newton plus 5 Newton. So now T max will be equal to 72 plus 5, which is equal to 77 Newton. Okay, so this is the maximum tension, mean in this part the tension will be equal to 72 Newton. If you find the T minimum, so just write the formula T plus W is equal to m omega square into R. So we already found this part, which is equal to 72 Newton in this part in the previous whenever we find the T max. So this part is equal to 72 Newton, and this one is also given, which is equal to 5 Newton, and this is T. So T minimum now, if we shift the value here, so this is equal to 72 Newton minus 5 Newton. So if we shift the value, so this will become 76 Newton. So now this is the T minimum at this point. So this is the T minimum value, which is equal to 67 Newton, and in this point is T max, which is equal to 77 Newton. Like here is the more tension, but here is the less tension is compared to the different position of the tension value. Okay, this is the horizontal and vertical side. This is the vertical side at minimum position and maximum position. On the next page, this is your homework. Already, if when you watch the centripetal force video, here they use a word horizontal. So I will give you some hands. You directly use this formula mv square by r, and you will solve this question. So this is your homework. Try to solve this question, and if you have any difficulty in the question, so inshallah you will ask in your comments, and then we will try to solve in the next video. Okay, thank you so much, dear student. Take care and best of luck. Thank you so much.